We're now going to start a series of videos on transformations. The first type of transformation we're going to look at are translations. On this first page, we're going to be doing translations of the function f of x equals the square root of x. So the first step is just to have a good idea of what that original graph looks like. I like to put on a few key points. In this case, I use some really nice, easy numbers. I use the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. And those are my three key points that are on the graph. Now I'm going to do some things to the function. The first two things I am going to do to the function happen outside the function. So when we do something outside the function, like this, adding 2 outside the function, or subtracting 2 outside the function, how does that affect the graph differently than if we add 2 or subtract 2 inside the function, which is what we do below? So I'm going to look it down here. We're going to be doing changes inside of f of x. So we have a change here that's inside the function. So how do those affect the graphs differently? So let's start with our outside the function translation. So we have here f of x, and we know that f of x is the square root of x, so we say that g of x then is the square root of x plus 2, where we do the square root of x first and then add 2 afterwards. So let's see how this applies to our key points. We can still use 0, 1, and 4 because those give us some nice numbers. So if x is 0, y is going to be the square root of 0 plus 2, which is 2. The square root of 1 is 1 plus 2 is 3. The square root of 4 is 2 plus 2 is 4. So the new points that I get from my transformed function are these points here, 0, 2, 1, 3, and 4, 4. Notice that the new graph consists of points that have just been shifted up 2 from the old point. So everything is going up 2. So it's just plus 2. This is a shift up 2 units. So when we talk about translations, we are talking about shifts in position. We get translations whenever we add or subtract from the function or from the x variable. So I bet you're going to guess that if we subtract f of x minus 2, that's going to just have the opposite effect, and it does. This just means this is going to shift down 2. So take each one of the key points and move it down 2 units, and there is our new graph. Okay, so everything just shifts down 2 units. Now let's take a look at what happens when we add 2 or subtract 2 inside the function. Now this is a little trickier. So if we think about taking our, well, first of all, let's see what it looks like when we change, when we apply the definition of our function, which is that f of x is the absolute value, or sorry, the square root of x. Now what do we do with the square root? Well, since f of x equals the square root of x, then f of x plus 2 is just going to be the square root of the quantity x plus 2. Now, my key points for x are 0, 1, and 4. But if I put 0 in here, I'm going to get the square root of 2, which is not a nice number to graph. If I put 1 in here, I'll get the square root of 3, and if I put 4 in here, I'll get the square root of 6. So when I realize that the x value is going to be changing, what I really want to do is think maybe about my y values first. I want to get nice y values. I want to get my y values that are 0, 1, and 2. So what I want to think about is, what do I have to change in x then to get back to those same nice values that I had before? Well, in order to get y equals 0, I'm going to have to take the square root of 0, so x is going to have to be negative 2. And in order to get the square root of 1, x is going to have to be negative 1. And in order to get the square root of 4, which equals 2, x is going to have to be 2. So when I put all of these in here and plot them, I get negative 2, 0, negative 1, 1, and 2, 2. And notice that each one of these points is just shifted to the left 2 units. And so my new graph looks like this. everything is shifted to the left 2. So shifts left 2. Now, interestingly enough, when you see this +2, you might think, well, that seems like it would move to the right in the positive direction, but it moves to the left. And the reason is because I have to compensate for the fact that I've added 2 to x before I take the square root. So I have to make my x values 2 less than they were before in order to get those same nice square root numbers that I had for y. So my guess is you probably know what happens here, but since the inside shifts are a little bit trickier than the outside ones, I'm going to go ahead and do this one with a t-chart. Once you learn the principles, you won't need to use the t-chart for each one of these, but I want to show you anyway with this. Once again, I'm not going to put in 0 for x and 1 for x and 2 for x, because I'm going to get, for 0 and 1 particularly, I'm going to get the square root of a negative number, which I can't even do. So what I'm going to do is think about, I want y to be 0, 1, and 2, so what does x have to be? Well, for y to be 0 here, x is going to have to be 2. So that shifts it to the right 2. For y to be 1, x will have to be 3. So 3, 1. And for y to be 2, this is going to have to be the square root of 4, so x is going to have to be 6. So I need the point 6, 2, which is actually a little farther over than I have, but I can kind of estimate where that would be, about right here. So notice we have a right shift on this graph. So what I want you to notice is when we make a change outside the function, outside change affects y. So we have some kind of a vertical change. In this case, up and down, shifting up and down. An inside change inside the function affects, let me see if I can write this better, affects x. In other words, we have a horizontal change, back and forth, side to side. So these are translations. Adding and subtracting shifts the graph in position, doesn't stretch it, just shifts it up and down, right or left. Adding outside the function, up. Subtracting outside the function, down. Adding inside the function, left. Adding or subtracting inside the function, right. Those are the translations.